Dear students, in this video, I will cover what is the basic difference between CISC architecture as well as RISC architecture. So, at the end of the video, you may get idea about what is CISC and what is RISC architecture and what the difference between CISC and RISC also detailedly. Let's see what is CISC, what is RISC. So here first RISC architecture. So name itself, it's a reduced instruction set computer. It's a one processor where we have reduced instruction set computer. Means the instruction set is reduced here. Means the number of instructions present in each operation is less here. That's why name comes like reduced instruction set computer. So see here it is built to minimize here the number of instructions are less and execution time is also optimal less, and limiting the number of instructions. So here two things we are doing at a time. One is we are reducing the number of instructions, and second we are reducing the execution time also. Okay, and here the instruction cycle takes only one clock. Within one clock cycle, the instructions are executing. Okay, and indirectly the fetching, decoding, and execution. So the fetching the instruction or decoding the instruction, similarly executing the instruction, everything will take only one clock cycle under RISC structure. And here in this architecture, we are making like complex instructions are combining them into simple ones. So wherever complex instructions are there, we are making like a simple instructions. That's why it is called as a reduced instruction set. And it requires less number of even in transistors. Okay, and we are using only transistors only under this structure. So the cost is less, and designing also simple, and execution time also less. So these are some of the features of RISC architecture. Let's see the diagram once. So this is our RISC architecture, and here we have main memory, hardwired control unit. So data path. Okay, so data cache separately and instruction cache separately. So here we have two caches are there separately, data cache and instruction cache. Here main memory. So data cache sending data to main memory, and instruction cache sending data to main memory, and data cache also sending data to main memory. So hardwired control unit will control both data path as well as instruction path also, like this. Hardware control unit controls data path, and that data path will send data cache to main memory. Similarly, instruction cache also controlled by hardware control unit, instruction cache sending instruction related information to main memory. So this is indirectly it's like a ROM, and this is indirectly like a RAM. And both are controlled by ROM operation as well as RAM operation controlled by hardware control unit is available that will control both operations. And finally, cache instruction information and the data information both will come to main memory. This type of architecture is called as a RISC architecture. Coming to other one is generally the RISC architecture generally follows like a software based architecture. So coming to CISC architecture, it's a hardware based architecture actually. So name itself is a complex instruction set computer. Okay, and it is invented by Intel company. So complex instruction set computer. So name itself, the instructions are somewhat complex. Because of complex instructions, the execution time is more. Okay, so it's a large collection of complex instructions that are present here. So here we are making like instructions are somewhat complex. Okay, so that's why it will take a longer time to execute all these instructions. And it emphasizes on complex instructions. So mainly it is usually like a hardware nature. Whereas previous one is software nature. So hardware always faster than software execution. Okay, so CISC chips are relatively slower as compared to RISC chip, because here we are using more instructions than RISC compared to RISC structure. Here CISC structure we are using more instructions, that too they are complex. Okay, so that's why they are a little bit slower rate as compared to RISC structure. Okay, so indirectly, these are some of the points. What's the final observation of CISC and RISC? CISC, we have complex instructions are there, and these instructions are processed through hardware nature, and the previous reduced instructions instructions are processed through software. And they're having less instructions. Here we are having more instructions. So your clock also, it requires more clocks to execute the instructions. So if you see the CISC architecture ones, here we have control unit. This unit will control both instruction and the data path, as well as this unit will control instruction and the data path. And we have separately micro program control unit is available. So micro program control unit is available, and this will control unit, and control unit will control both instruction path as well as data path. And finally, it will come to one cache memory only. Whereas previously we have separate data cache and instruction cache. Now we have only single cache, and that cache will send data to main memory. Okay, so here instead of Harvard control unit, here we have micro program control unit is made available in the CISC architecture. That will control unit, then to instruction and the data path. From that, it will come to cache memory, then cache memory to main memory. So this is the basic difference between CISC structure with RISC structure. So let's see the examples of CISC processors. So I already mentioned it comes under like a hardware nature. So IBM 370, 168, VAX 11780, Intel 80486, all comes under CISC structures. Whereas RISC comes under like smartphones, even tablet computers, even supercomputers, all introduced CISC mechanism, CISC architectures only. All introduced RISC architecture only. Because of RISC nature, we have less number of reduced instructions only. So the execution rate is somewhat quicker here than CISC processors. And like applications point of view, so generally the RISC is used mainly in video processing and telecommunication and image processing applications, whereas CISC used in the low-end applications like home automation applications, security systems applications only. Okay, so RISC having advanced features, whereas CISC having conventional features only. That's why it is used like low-level applications, whereas RISC used for high-level applications. Coming to the comparison between RISC and CISC. So I already mentioned RISC is a reduced instruction set computer, whereas CISC is a complex instruction set computer. So RISC is related to software operation, whereas CISC is related to hardware operation. Okay, so here we are using hardware control unit. Here we are using a micro programming control unit is made available. So it requires multiple registers. It requires single register set only. Okay, so here this side RISC is decoding is somewhat simple, whereas CISC somewhat complex. So here pipelining mechanism is difficult. Here pipelining mechanism is simple. So here limited number of instructions only. Here large number of instructions are present. So here register to register operations are introduced for performing load and store operations. Here memory to memory programming related instructions are used to perform load and store related operations. Okay, here RISC has more transistors, whereas CISC has less number of transistors only, but instructions are complex. Execution time is short here, whereas in the CISC execution time is longer. So RISC is used in high-end applications like image processing, video processing, telecommunication applications. CISC is used like low-end applications like home automation and security systems applications. It has fixed format. It has variable format. Instruction format is fixed. Here it's a variable. Okay. So RISC requires it will take more space, whereas it will take less space. Memory space is less here because of reduced instruction set. We written many instructions with instruction wise less, but it occupies more space. Here it occupies less space. So the example for RISC include like ARM, AVR, Alpha, Spark, ARC, all comes under examples of RISC only. So examples of CISC includes like Intel 886 CPUs, Motorola 68000 family, 360 related sequence number, AMD, all comes under examples of CISC only. Okay, so I think this video covers the basic CISC structure, RISC structure, and applications of RISC and CISC. Similarly, the comparison of RISC and CISC. Okay.